Now let's talk about some periodic trends. Okay, so let's talk about then the radius. So remember, the radius is the distance that the outermost electron or the valence electrons are from the center. That's really what we determine would be the radius of an atom. And from left to right in a period, the radius decreases. And again, you say, wait, now that makes no sense. You add more electrons in, wouldn't it get bigger? No, it gets smaller because as I add more electrons in, that core charge is getting bigger and bigger. So I'm having more core charge, which means that the outer electrons are being pulled more forcefully in towards they're attracted towards the nucleus more, and therefore the smaller the atomic radius. So this is not what we say is not an intuitive trend. So it's one you have to work to counter, because your brain is probably going to say as you add electrons, it's going to get bigger, but in fact as you add electrons, it gets smaller. And then from top to bottom in a group, the radius increases. So this one is intuitive. As the principal energy level increases, the farther the outer electron is from the nucleus, and so the radius increases. And remember, we talked about as you go down the group to further and further periods, higher and higher periods, that the electrons are going to be in higher principal energy levels. So we can sort of visualize it here on a table. So I'm going to get higher and higher radius as I'm moving to the left, because as I'm moving to the right, I have more core charge pulling them in tighter. So I've just flipped it to make it a little easier to see. So it's going to increase going from right to left within a period, and it's going to increase going from top to bottom within a group. Overall, that's giving myself sort of a diagonal trend, so that cesium on this table, it's not showing group 7, period 7, but period 7 is really francium, is the largest element, and helium is going to be the smallest element in terms of radius. So I might ask you something like, which one has a bigger radius, oxygen or nitrogen? Well, in this case, I'm going to use this increasing radius going to the left and say nitrogen is going to be the bigger radius. Or if I asked you about aluminum and gallium, you would say gallium would be the bigger one because I'm using this trend. And if I asked you about gallium and fluorine, you'd say gallium because it's both. Now, ionization energy is another periodic trend. Now, of course, that first means what is ionization energy? We need to define ionization energy. And we kind of talked about it a little bit when we were calculating with the Rydberg electrons in the Bohr atom. That's the minimum energy required to remove an electron from an atom. I can kind of think about it in my mind as being, how hard is it to create a cation? Remember, a cation is losing one electron and becoming a positively charged ion. So if it takes if it's very hard, it's going to take a lot of energy and have a high ionization energy. And it turns out the ionization energy increases going from left to right across the period. And again, it's because as we go from left to right, I'm getting a higher core charge. That core charge is holding those electrons, valence electrons, in tighter, and they're harder to remove. And it increases going up a group. Remember, as I go down, they're farther and farther out, and of course, farther out means it's less tightly pulled from the nucleus. As they're on the low energy levels, they're very close to the nucleus, and so they're going to be held more tightly. So ionization energy is going to be doing the reverse of radius. As I go up a group, the ionization energy increases, and as I go from left to right, it increases. So helium is now going to be my highest ionization energy element, and cesium, or even below it is francium, is going to be my lowest ionization energy. So note, in general, we see that these blue, which is my metals, yellow is my nonmetals. Remember, hydrogen is always a deal breaker. Hydrogen is nonmetal, even though it's left of the staircase. My green are my metalloids. So my blue ones are going to be in a part of the periodic table with low ionization energies. And that turns out to be pretty important because metals are going to lose their electrons. They're going to form cations, and that's because they have low ionization energies. It doesn't take a lot of energy to remove them. And fluorine and oxygen and chlorine are going to they have very high ionization energies. Electron affinity is pretty similar to ionization energy. We see the same trend. It's a slightly different terminology. So electron affinity is how tightly held is that. That is not the right definition. Electron affinity is the affinity or desire, how easy is it for it to get another electron, to form a negative ion, an anion. I'll have to fix the notes, sorry about that. So again, for the same reason that fluorine can attract an additional electron and become a negative ion because it has a high core charge. It has a high core charge, and this is an energy level that is fairly close into has a low radius. It's close to the nucleus, so it's going to be feeling the effects of those core charge very strongly. And so fluorine can easily make a negative ion and attract an additional electron. Another related thing is the electronegativity. The electronegativity is similar to electron affinity. However, it is the ability of an atom to attract an extra electron within a bond. So the difference between electron affinity is it's talking about an atom that is not in a bond, and in electronegativity we're talking about within a compound when we have bonded electrons. It turns out it's going to be a pretty important feature for us when we're talking about bonding in the next unit, so I wanted to kind of bring it up. And it does the very same thing. It increases going across a period from left to right, and it increases going up a group from bottom to top. So I see that it's going this way. I will say that we notice that the noble gases are redded out. That is because you can't fit an additional energy electron into this energy level, so it doesn't bond. So really fluorine is going to be my highest electronegativity element. Okay, so I kind of got some yellow here. So which has a larger radius, arsenic or bromine? You'll use the periodic table and these periodic trends for radius to answer that. This is, it didn't appear very well, it's in yellow. Which has a higher ionization energy, tungsten or zinc? Again, use the periodic table, use the periodic trends for ionization energy to make this determination.